Sir Thomas Little Heath, who is responsible for the modern English translation of the Elements, said, "Euclid's work will live long after all the textbooks of the present day are superseded and forgotten. It is one of the noblest monuments of antiquity. No mathematician worthy of the name can afford not to know Euclid." So what exactly is the Elements, and why is it so highly regarded? To understand this, we need to look at some history. Specifically, the history of one of the oldest forms of mathematics, geometry. The word geometry comes from the Greek word geometria. The first part, geo, means land and is the same prefix we see in words like geography or geology. The second part, metria, means measurement. So geometry literally means land measuring. Measuring land was, of course, a matter of utmost importance for early civilizations, as they needed to do things like track how many crops were grown and determine the appropriate rates of taxation for the farmers. As an example, we will look at a math problem from the Rhind Papyrus, which was written in ancient Egypt in approximately 1550 BC. The author gives a procedure for calculating the area of a round field, meaning circular, of diameter 9. We are instructed to take away 1/9 of the diameter, leaving us with 8, and then multiply the result by itself, giving us 64. This is very close to the actual area, but is not exactly correct. The Egyptian method tells us to multiply the diameter of a circle by 8/9, and then square the result to find the area. This is just an approximate solution since we need to know the value of pi to calculate the exact area, and pi is an irrational number, which is something that was not well understood until much later on. Notably, this Egyptian value is always slightly larger than the actual area, which would have meant slightly higher taxes paid to the pharaoh. So the two ancient civilizations from this part of the world which left mathematical artifacts were the ancient Egyptians and the ancient Babylonians. On the left here we have a piece of the Rhind Papyrus, which contains several mathematical exercises and their solutions. And then on the right we have Plimpton 322, which is a clay tablet that was made by the ancient Babylonians in approximately 1800 BC. This clay tablet contained a table of Pythagorean triples. The clay tablets used by the Babylonians are extremely durable, so quite a few of them have survived. While we have evidence of some sophisticated mathematical results from these civilizations, they left no records of the methods which they used to discover these results. Both of these civilizations had large central governments and very rigid social hierarchies, which meant that questioning orders from above was not permitted. Additionally, they both had organized priesthoods. The priesthoods were actually the source of many of the mathematical results from this time, since the members of the priesthoods were some of the only people in these societies who had leisure time in which to work on mathematical problems. However, this also meant that the results were tied in some way to religion, which further prevented any kind of questioning. Ultimately, both of these cultures were constrained in ways that limited their scientific progress. Then we come to the ancient Greeks. So if we look at the geography of Greece, we see that there are a lot of mountains and a lot of small islands. As a result, rather than a single central government, the ancient Greeks established a number of small city-states, each with their own government and laws. As the city-states nearly all had access to the Mediterranean Sea, trade flourished, and they started establishing colonies all around the Mediterranean and up into the Black Sea as well. By around 600 BC, they had spread to North Africa, modern-day Italy, the coast of modern-day Turkey, virtually every island in the Mediterranean, and even parts of what is now France and Spain. When we talk about the ancient Greeks, we therefore are not just talking about the people who lived in what is now the country of Greece. We are talking about a large and diverse group of people who were united by a common language and a common culture. During this time, becoming a traveling merchant emerged as a good way to become wealthy. As being a traveling merchant afforded one a large amount of personal freedom and required some intelligence to be successful at, these merchants became some of the first of the ancient Greek philosophers. And speaking of which, the defining feature of the ancient Greeks was probably their tradition of philosophers. Not only did the Greeks have a system of government which encouraged free thinking and debate, they also had no organized priesthood. This meant that they could take the knowledge accumulated by the previous civilizations and build on it with no restrictions. Indeed, the ancient Greeks came to believe that it was not only their right, but their duty to attempt to learn and understand as much about the natural world as possible. They believed, in the words of T.L. Heath, that there could be no impiety in the pursuit of truth. They did not rest until they had found a reason or explanation for every phenomenon they observed. Additionally, and this was very important, they did not accept statements without a convincing proof. It is really impossible to overstate the impact that the ancient Greeks had on scientific thinking. Mathematics at this time was divided into the quadrivium, which consisted of geometry, arithmetic, astronomy, and music. They didn't just study these subjects in an applied sense either. They loved abstraction, and geometry in particular was held in the highest regard. Legend has it that above the entrance to Plato's famous academy in Athens was the phrase, "Let no one ignorant of geometry enter." We move forward now to around the year 300 BC, which is after the time of Plato and Aristotle and right after the death of Alexander the Great. The empire that Alexander the Great conquered was split up after his death among a number of successors, and Egypt went to a man named Ptolemy. In a port city in Egypt named Alexandria, which of course was named after Alexander the Great, Ptolemy set up the famous Museum and Library of Alexandria. In this context, the word museum means a temple of the muses, which had become places of study and learning. In order to build up a collection of scholarly works, anyone sailing out from the port was instructed to bring back scrolls from wherever they traveled. Additionally, scholars who lived and worked at the library were given free room and board and a salary. As a result, the library built up a massive collection and replaced Athens as the center of higher learning in the ancient world. Euclid was one of the scholars who lived and worked at the Library of Alexandria, but despite writing the greatest textbook of all time, we know nothing for certain about his life. He probably did his work somewhere around the year 300 BC, and it is believed that he studied with Plato's followers in Athens before coming to Alexandria, since this is where the leading experts on geometry lived at this time. The Elements is a 13-volume work written by Euclid, whose purpose is to teach elementary geometry. The word elements used in the title is the same word that was used by the ancient Greeks for the letters of the alphabet. And similarly, it is meant that the contents of the elements are the fundamental pieces of geometry. Euclid was not the first to attempt such a work, but he was certainly the most successful, and his book quickly became the standard textbook for elementary geometry. In some sense, the work also serves as a compilation of all of the elementary results that have been proved so far. Most of the proofs were therefore not discovered by Euclid. His great achievement was fitting them all into a single logical structure. Since the book was so popular, people started reproducing it with their own commentary. The most famous of these from this time period was written by Proclus in the 5th century AD. Now, the Elements remained popular after the time of the ancient Greeks as well. For example, the ancient Greek works were translated into Arabic during the Islamic Golden Age. The picture here is of the Baghdad House of Wisdom, which was an institution similar to the Library of Alexandria. The Elements was probably first translated into Arabic in the 9th or 10th century AD. Eventually, the Elements showed up again in Europe. The printing press was invented in Europe in the year 1440, at the start of the Renaissance. They immediately began printing the ancient Greek classics, but geometry books were difficult because they contained a lot of diagrams, which the printing press couldn't handle. This issue was eventually solved by a German printer living in Vienna by the name of Ernhard Ratdolt. He published the first printed edition of the Elements in 1482. Since there had been so many translations and commentaries at this point, there was disagreement as to the original contents of the Elements, so many other editions appeared claiming to be more accurate. In total, there have been more than 2,000 editions of the Elements printed, more than any other book except the Bible, and it has continued to be the gold standard in elementary geometry. The current English translation, which is in use, was done by the math historian T.L. Heath and published in the year 1908. So if we are going to study geometry, we will need some tools for doing our geometric constructions. For this video series, I will be using a piece of software called GeoGebra, which I highly recommend downloading. It is available for free on their website and is fairly easy to use. I'll go over how to use it a little bit in the next video. I strongly recommend trying out the constructions yourself rather than just watching them being done, and I will also be providing practice problems to try. Now, if you want to do things the old-fashioned way, you're going to need a compass and a straight edge. The compass is used, of course, for drawing circles, and the straight edge for drawing straight lines. Note that you don't need specifically a ruler for your straight edge, just anything that will let you draw straight lines is fine. You definitely don't need to do things by hand, but it is kind of fun to try out at least once or twice. Note, however, that as the constructions become more complex, it will become more difficult to do them on paper, so at that point using software will probably be preferable. Now let's talk about the different editions of the book which are available in English. So these are the T.L. Heath books. They are split into 3 volumes. As mentioned, T.L. Heath's is the standard English translation in use today, so this is the translation we will be using. However, the books are pretty dense and they contain a lot of extra history and stuff, so I don't really recommend reading T.L. Heath as your first exposure to the elements. What I do recommend is the books published by Green Lion Press. So this picture is of one of the Green Lion books, which contains all 13 volumes of the elements in a single book. The Green Lion books also have some really nice formatting choices. For example, diagrams are duplicated so you don't have to flip back and forth between pages a lot, which is really nice. And in addition to this copy of the elements, Green Lion also has one which contains only the first book with some added questions, and that one is a great introduction if you don't want to go for the full book. There are also a couple of versions which are available for free online, so let's talk about those. The logo on the left here is from the Clark University online edition, which should show up if you search for Euclid's Elements in any search engine. There is also the version on the right, which is interesting. It contains colored diagrams, and then the proofs reference the different colors used in the diagrams, so it's maybe a little bit easier to follow. This version is available as a physical copy and also for free online. It does only contain the first 6 books of the elements, however. So in summary, if you don't want to spend any money, you can use GeoGebra and the Clark University edition. If you do want to buy some physical items, I again recommend the Green Lion Press books and just a simple compass. To conclude, I'll just leave you with one more nice quote about the elements from the mathematician Bertrand Russell. He says, "At the age of 11, I began Euclid with my brother as a tutor. This was one of the great events of my life, as dazzling as first love.